These are the notes for 4.1 Part B. We're looking at trig integrals and differential equations. Let's review derivative rules, trig derivative rules, to see where these trig integral rules are going to be coming from. So we know the derivative for sine is simply, sine of u is simply cosine of u times u prime. The derivative for cosine of u simply negative sine of u times u prime. Tangent of u is secant squared u times u prime. Cotangent of u, negative cosecant squared u times u prime. Secant u is secant u tangent u prime. And then cosecant u is negative cosecant cotangent u prime. All right, we talked about how there are some patterns here. The tangent and cotangent share a similar form in their derivative. Secant and cosecant share a similar form in their derivative rules. And all the functions that start with c will give you a derivative rule that will be a negative function. Now, trig integrals, we talked about how integrals simply will be inverse operations of derivatives. So we're going to see that in this case as well. So if we know that the derivative for sine is cosine, then it should make sense that the integral of cosine will give you sine. Okay, so that's what we have for this rule here. The integral of cosine of u du is simply sine of u plus c. We talked about how with indefinite integrals we always have to include a plus c to show that there's a family of functions that share the same derivative. Okay. Likewise, if the derivative for cosine is negative sine, then the integral of a positive sign would have to mean that this negative will have to go somewhere, has to go back on the other side. So if the derivative for cosine is negative sine, then the integral of sine will simply be a negative cosine, right? And that's what we have here. Integral of sine is simply negative cosine. It may seem off because we're used to seeing sine turning into cosine and cosine turning into negative sine. But remember, we're going the opposite direction, so the signs will be may seem a little off. But if we think of it as going back to where we're coming from, then it should make sense with the negatives and positive. Okay? The integral of secant squared is simply tangent because we know the derivative of tangent is secant squared. The integral of cosecant squared is simply negative cotangent, because we know that the derivative for cotangent is negative cosecant squared. So if I want to find the integral of a positive cosecant squared, then this negative will have to go to the other side. Okay. Integral of secant tangent is secant u. That's coming from our derivative rule. And then integral of cosecant cotangent is coming from this rule, negative cosecant u plus c. Okay, let's look at some examples. The integral of 1 plus cotangent squared of x dx. Now we're going to see that we don't have a specific rule for cotangent squared x. All right, if we compare 1 through 6, there's none that will fall into this category. However, we do have trig identities at our disposal. Hey.